This next problem says how many calories of energy are needed to boil off 96.7 grams of water at 100 degrees Celsius. So water boils at 100 degrees Celsius. We don't need to change the temperature at all. We just need to figure out the energy needed for the phase change to happen. So boiling. For something to boil, that means that it's going from the liquid phase into the gas phase. We also call that transition vaporization. So when we do this calculation, we are going to use our equation Q equals m delta H, but instead of using delta H of fusion, we're going to use the delta H of vaporization. So we're going to use Q equals m times delta H of vaporization. And our delta H of vaporization value is on our sheet as well. For water is 2260 joules per gram. So 2260 joules per gram. And our value of m is given in the problem, and it's already in grams. So we know that our units are going to cancel out nicely. So our value for m is 96.7 grams. And that's all equal to our value for Q. Okay. So when we do this calculation, our units of grams is on top and on bottom, so that will cancel, and we'll just be left with joules in our final answer. And that is appropriate because we are looking for energy. However, it's not the final unit that we want. The question specifically asks for energy in the unit of calories. So once we get our answer in joules, we will need to do some dimensional analysis to convert to calories. And we know, of course, how many calories and joules are equivalent to one another. We can use that information once we get our answer in joules. But first, let's do Q equals, okay, we do 96.7 times 2260, and that gives me 218,542 joules. And we don't want to round this value because it is an intermediate value. So we're going to hold on to that for a second. Alright, and now that we have our answer in joules, we need to convert that to calories. So we're going to start with 218,542 joules over 1. We want joules to cancel, so joules goes on bottom, calories goes on top. And we know that theirs is not a metric conversion, so we do just have to know the conversion factor. And we know that there are 4.184 joules per every 1 calorie. So now we just need to divide this out. Oh, let's try and get the calculator where you can actually see this. Let's see, so we have 218,542 divided by 4.184. So I have that, and my answer is 52232.79. And of course, my new answer is in calories. And last but not least, I just need to round to appropriate significant figures. Looking back at my problem, 96.7 has 3 significant figures, and then 100.0 has 4 significant figures. So I'm going to round to the least number of sig figs, which is 3. So looking at our answer, we will keep the 5, the 2, and the 2. And then we'll look at that next number over to determine whether the 2 will round up or stay a 2. A 3 is not larger than 5, so we're going to keep 5, 2, 2. And then any place before the decimal point, we have to put a placeholder 0 to hold that place. But these zeros are not significant because there is no decimal point. So 52200 calories. or 52,200 calories is our final answer.